Good morning, my LeetCode friends, and today we're having another problem that we have to solve. Zero array transformation, medium one. You are given an integer array nums of length n and 2D array queries, where queries I equals to li ri value ai, 2D array queries li. Each queries I represents the following action of nums. Decrement the value at each index in the range li ri in nums by at most value I. The amount by which each value is decremented can be chosen independently for each index. Zero array is an array with all its elements equal to 0. Return the minimum possible non-negative value of k such that after processing the first k queries in sequence, nums becomes a zero array. If no such k exists, return -1. Okay, I don't understand. Nums 2 0 2 queries 2 0 to 1 0 to 1 1 1 3 output 2 explanation. If we're making a loop, L0 R2 value 1, decrement values at indices 0 1 2 by 1 0 1 respectively. The array will become 0 1 0 1. I equals to 1. Decrement values at indices 0 1 2 by 0 1 0 1 respectively. The array will become 0 0 0, which is a zero array. Therefore, the minimum value of k is 2. LR1 0 2 1 0 minus 0 minus 0. Well, let's read it again. Integer array nums and integer queries where queries I li value I. Increment the value at each index in the range li in nums by at most value I. return the minimum possible non-negative value k, such that after processing the first k queries in sequence nums become a zero array. Okay, let's look at the next example. Decrement values at indices 1, 2, 3. L R value. Decrement the value at each index in the range L I R I by at most value. So we're having a range from 0 to 2, and we can decrement it by at most 1. And we're decrementing it by 1, 0, 1 respectively. Yes, at most 1. So we can apply different decrement values for each one, but maximum 1. But at indexes from 0 to 2, so all indexes. Here also all indexes. And here we can decrement it by 1. In the end we will have 1, 0, 1, yes. After that we can also do the same, and we're finishing with that. We don't need next iteration. This is why k is 2, because we only need 2 iterations to make our array 0 array. After that, here we have this sequence. We should decrement. Okay, let's not look at the example. We should decrement each element by indexes from 1 to 3 by 2 maximum, which means that in the end we will have 1, 0, 0. After that, from 0 to 2 by 1, from 0 to 2 by 1, we will have 3, 0. And in the end, we will... No, it's not a 0 array, which means that we should return false. Perfect. Let's write this down. What do we have? We should create k variable, which is 0. It would be a number. And that's it, I think. And we should have the loop out of queries. Here we have left, right, and max decrement. Now, what we should do is to decrement every next value. I think we can say that our numbers array is not immutable, and we can mutate it. Const. No, we should have a loop. Do we have a condition that L is always less or equal to right? Yes. Value is always bigger than 1, is bigger than 0 and less than 5. Queries length always 3. Well, let's just think about one thing. Can we optimize this algorithm somehow? Because I think yes. We will need a little bit more memory, but we can summarize all the values that we should decrement, and after that only make one loop through the final array. It would be the same complexity, because what I mean, if we have this sequence, then we can just create a 0 array at the beginning. After that, we should increment all of this. Yes, it would work. So 1, for example, 1, 3, we will set 2, 2, 2, 0, 2, 1. So 1, 3, 3. Here we can say that we should return -1 here, because not all the numbers are equal or bigger than initial ones, but we cannot say how many iterations should we make, so we will not be able to return k. What is also can be good, early exit, of course we will do it, but I don't think we can simplify it in some other way. Okay, let's say that I equals to left, I less or equal to right, I plus plus. Const is 0 array equals to true. Let. Yes, it would be a boolean. And we need to say that is 0 array true. They can be equal, so we cannot say that they are true. Okay, let's make it a little bit later. After that, we should say that numbers I minus assign max decrement. Okay, we should do this thing. If left equals to right, we should just continue our loop. Then it makes sense. next value. I will add one extra variable just to make my code more readable. It's next value. If next value bigger than 0, then a 0 or array would be false. K plus plus. Yes. Left, right, left, right, minus or equal to right. I'm not sure we can write like this in TypeScript. I++. Next value would be numbers at index I minus max decrement value. Then we will say that numbers, we will assign this value, and if it is bigger than 0, then we say that at this iteration it is still not a 0 array. In the end we will returning -1, but if it is still 0 array, then we should return value. If it is 0 array, then we should return final value. Okay. I think it should work. Let's check if everything is okay. To be honest, when I thought about TypeScript in LeetCode, I thought that LeetCode would help solving the problems by highlighting TypeScript errors, but it makes only more complicated to solve, because it only checks your TypeScript types, which is funny. Okay, K is a 0 initially. We're always incrementing it in the beginning, which is okay. After that, if left and right are equal numbers, then we just continue, or we don't continue, because I could be equal to right. And this, yeah, and I have a mistake, because I only checking a 0 array by the numbers that I looped through, but not those ones that I did not loop through. Okay, one more challenge. So I need to check all the numbers every time. How we can make it optimally? We can say that there is a special number of positive values in numbers array, and every time when value will become negative or 0, then we will decrement this value. Const number let number of positive values equals to is, let's just reduce the array. Reduce, initially it's 0. Previous next return if next bigger than 0 then previous plus 1, in other case just previous number. And we should make sure that there are no negative numbers. Yes, there are no negative numbers. Okay. If next is bigger than 0, then we will increment previous value. In other case, we will just return previous value. If yes, it should work. Number of positive values. Current value is nums I. Next value is current value minus max decrement. Then we are assigning it, and if we should remove this condition. Okay, if initially number of positive values equals to 0, then we return 0. In other case, we know that there are positive values. Okay, if number of positive values equals to 0 after all iteration down, we should return k. Yeah. What we also have here. Now we should decrement number of positive values. If current value is bigger than 0 and next value is less or equal to 0, then we should decrement number of positive values. To make it even more simple, we can do this. Just not to finish every loop. If we already know that we have this number here, but then we will have more conditions. In every loop we will have to check. Okay, I will but I don't know if it's okay. I think yes, that would be better. Yes, it will certainly be better because we can have like very big arrays. Okay, let's check it again. Considering all the conditions that we already have. We have number of positive values which we assign in the beginning by counting the amount of positive numbers in the array. Should work. After that, if it is already equal to 0, then we are making early exit with 0. Then we are having k variable, which is initially 0. It would contain number of iterations that happened. We're incrementing it in every query, and here we have 3 values: left, right, and max decrement. After that, we're making a loop. We'll go through the array in a loop from left element to right element. We're getting current value, we're calculating next value, we're assigning this value, and after that we're checking if this value became negative, it was positive but it became non-positive, then we're decrementing number of positive values. And if in the end, after this iteration, we are having number of positive values equal to 0, then we return number of iteration. I think it should work, and I cannot imagine the easier or more optimal solution. Let's check. Maybe we can somehow calculate first. No, we should loop this array anyway. Let's run. Yep, everything works. Let's submit. Time limit exceeded. Wow. Really? Really? We should optimize it somehow. Let's look at the solution, how we can optimize it. If we're having really big array and really big amount of, so we actually have a lot of iteration. We're going every time we're going through the whole array, which makes our algorithm quadratic. Are we able to simplify it somehow? Are we able to simplify it somehow? We can go through all values. But we have to decrement every value anyway, I believe. And here we have equal values of every decrement. But in real life we can have different values. So we cannot say that it is as easy as that. I should decrement it by 5. how to make it more optimal. Just to make it not quadratic. We can revert this loop and make run through numbers, and then for every number run through queries, and calculate every element. In this case, it would be more optimal if we have not so many numbers, but a lot of queries. But it will not simplify the final complexity. Well, what we can also do here, what can we also do here? 500,000. 500,000. We can create, we already have like store of this value numbers. We can, for example, skip numbers of or ranges of numbers that are already equals to 0 or negative. But it doesn't matter. Let's make this, for example. If current number is already less or equal to 0, then we will not calculate everything else. But I don't think this is complex. Continue. This is the reason of time limit exceeded. No, this is not. Well, how can we also solve this problem? How can we make it more? How can we create more optimal solution? Maybe something is in initial conditions. Array of nums of length n to the array queries, where queries is each queries I represent the following action of numbers. Increment the value at index in the range LR in nums by at most value I, the amount of which each value is decremented can be chosen independently for each index. Yes. Zero array is an array with all items all elements equal to 0. Return the minimum possible non-negative value of k such that after processing the first k queries in the sequence first, so we cannot choose the sequence, nums becomes a 0 array. If no such k exists, return -1. Numbers can be a big array. Numbers can be big. Queries length can be a big number. Queries I length is always 3. Yes. And value. What do I see here is that value can be pretty small number. It's always small number. Of course, we can check for our condition that every element of queries is the same. Then we can calculate it, but I don't think it would be a good solution. Okay, what can we do? I have no ideas, to be honest. So, let's look at solutions. JavaScript, for example. You're using a list of queries. Each query applies a range update, decrementing, and subarray by a given value. A binary search approach is optimal to determine the smallest number of queries required to achieve goals. What? Sorry. No, don't understand. Solutions. Binary search. Binary search of the number of queries. Perform a binary search on the number of queries to find the minimum required operations. Range decrement using difference array. Use a difference array to efficiently apply multiple range updates. For each query within the current mid, decrement the specified range in delta. Compute the final modified array using prefix sum. Okay, let's see. Is 0 array. Numbers, queries, middle. Numbers length. Delta. Yes. If left less than right. Mid would be math floor left plus right divided by 2. If it is 0 array, numbers queries made left right. Still don't understand. If r plus and 1 nums queries if I less than mid I plus plus, then we're getting these values from queries. Okay, and delta at index L we were decrementing it by value. Okay, so in the end we will get delta array if r plus 1 less than n, numbers length then delta r plus 1, we will increment it by value. Current decrement. Queries I. Okay, here we calculate the final decrement. So why do we need binary search here? For example, let's just imagine that we're having an array delta would be 0 array minus equal to v. right. Oh yeah, so we're having this kind of array where we will have decrement how will we have an array of numbers of deltas, yes, where that we should that would be decremented, and this deltas can be calculated. Yes, we can just use this delta every time. After that, temporary array would be changed, and we can make a final decrement, final summary, and if it will still be bigger than 0, then we're returning false. It's not a 0 array in the end. But why do we need binary search here? I don't understand. We need binary search to find the number of combinations. Yes. But deltas would be the same. We don't have any reason to calculate this delta every time. Okay, let's try to do it like this. Deltas is an array of length, numbers, length, filled by 0. I don't understand why do we have this +1 still for now. 4. Now we have to make a loop through the queries, and let I equals to 0, I less than queries length, I plus const equals to queries I deltas left minus or equal to minus a sign. Max decrement. After that, deltas right plus 1 plus assign max decrement. But only if right plus 1 less, only if right less than query's length, only if right less than numbers length minus 1. If right is equal to the index of the last element, then we should do nothing. If it's less, then yes, then we should do this. After that, we can go through our array. I equal to 0, I less than numbers length I increment current decrement equals to zero if current decrement would be changed by deltas I number array current decrement number I number if we also need k value, k would be incremented here. Still need to return -1. We will not be able to calculate the count of operations this way if we will just traverse all the array. This is why we needed binary search here. Now I understand. because we don't understand which query is assigned to which deltas. How can we make it work? I don't know. Only binary search? Only binary search. Binary search in which we calculate deltas every time and check all the other conditions every time. If after decrement numbers I plus current decrement it is not a decrement, it is a delta. Current delta. If numbers I plus current delta bigger than 0, then we return false. In other case, we return k, but k would always be equal to numbers length. This is why here we just return true. Now we have to make it binary search. Now we have to make it binary search. And to do that, we will always have left 0, and we only need let's name it max index, which would also be number.
Доброе утро.
And now we have this algorithm. Now we have max index variable that would say that we only count numbers until this one, I would be less or equal to max index. Here we count decrements, and after that we're going through the array in a loop, and then we go through the whole array. Yes, it should work. Yes, zero array. Boolean. Max index. Yep. And now what we do? Let left equals to 0, let right equals to nums length -1, while true mid index will be equal to math floor left plus right divided by 2. Well, interesting. How can we check where we should move? For example, we would say that the middle value is 0 array. It's enough to create 0 array. We should find the combination where the next one would be 0 array and previous one would not. So every time we should check it twice. How they would do it here? They always say that the answer is middle, but they don't break the loop in this case. So if is 0 array nums queries and mid index max index, if it is 0 array, then we should remember that result is -1. Return result. If we have this 0 array, that we know that result exists, and result would be at least mid index. Result would be equal to mid index plus 1. Why? Because, for example, if mid index is 0, and we have and this condition is met, then we should return 1. Yes. And in this case, we should move our pointers to left equal to mid index. In other case, if we know that we did not reach 0 array, we should move right to the mid index. In the end, what we will have, if left equals to right minus 1, then we should return result. Here we're moving left, here we're moving right pointer. Well, it's more complicated than previous solution, but let's check if everything is okay. Here is number -1, return the result. We don't have to return it here. Actually, yes, while left is not equal to right -1, or we can simplify it, left less than right -1. If left less than right, if left is equal to right, then we should stop it. Would it be equal? No. Let's check it on an example. For example, 0 to 0, left is 0, right would be 2 nums length, result -1, left 0 less than 2 -1, yes. Mid index would be 2 divided by 2, 1, and we are calling this is 0 array nums queries mid index 1. Deltas would be left, right, max decrement, queries I, for example, I 0 to 1, max decrement from 0 to 2, it would be -1, After that it would be minus 1, 0, 0, and right less than nums length minus 1. Nums length 3, minus 1, 2, right less than 2, 2 less than 2, false. We will not do anything with that. After that, what we will do? Current delta. Current delta would be 0. I equal current delta minus 1. Numbers I plus current delta no. Here we have two iterations because max index is 1. The second iteration would be the same, 0 to 1, and we will have minus 2 again. Yes. Current delta would be minus 2 if numbers I, 2 plus minus 2, 0 bigger than 0, it's not bigger than 0. We will not return false. Next iteration, 0 minus 2 minus 2, 0 minus 2 bigger than 0, false. Next iteration, 2, 2, false. So is 0 array? Here we will return true. Is 0 array true? Result would be mid index plus 1. Mid index is 1. Result would be equal to 2. Yes. Left would be equal to mid index. Left would be equal to 1. And we're going to the next iteration. Left less than right minus 1. Left is not less than right minus 1. We're returning the result. Result is 2. Looks like it should work. Let's check the next condition. 4, 3, 2, 1. Queries. Let's start from the beginning. Left would be 0, right would be 3, result minus 1, condition is met. Mid index would be 1. Sorry, mid max index would be 1. Deltas would be here we're taking max index. Whoa. Left, right, here we should have queries length. Yep. And queries length in our case would be 2, which means that right would be 1. And mid index would be 0. max index would be 0. After that, what we have in terms of deltas, we will have only one iteration from first element would be 0, then up to third would be minus 2, minus 2, minus 2, minus 2. After that, we're going here and checking that every element current delta first iteration it would be 0. First iteration it would be 0. Nums I 4 plus 0 bigger than 0, yes, we're returning false instantly. We're moving here, and right is becoming 0. Well, it is a little bit strange, because if we know that we're not having 0 array, then we should move our pointer left, not to the right. Yes. Left would be mid index, and mid index is 0. We already have it. Here we can just have an infinite loop. Maybe we should have some kind of mid index plus 1 or something. We should always make sure that our our mid index is changing. For example, if we have left 0, right 1, mid index would be 0. If we should move right, then if we should move right pointer, and we will take the left side, maybe like this.
Please provide me with more context or information. Take can be used in many different ways. What are you taking?
How can we move it right? No. Well, for example, left equals to 0, right equals to 3, mid equals to 1. Yep, but if left equals to 0, right equals to 1, mid equals to 0. And there is no reason to say that we should assign mid to left. We should always assign mid to left, mid plus 1 if we want to move right. But let's see at this condition. For example, this mid 1, we want to move left. Well, let's see how they did it in the solution. Wow, they're decrementing it by 1. So in this case, what we want to say, if mid doesn't satisfy this condition, that we will want to make left equal to right. Yes, why not? And this condition would make sense in this case. Left can be equal to right. Okay. Let's start from the beginning. It will not be changed for first iteration. Now we have it index 0. Right would be 1. Left would be 0. Mid index would be 0. Next, left. We know that it is not a 0 array. This is why we're moving left pointer to the mid index plus 1. After that, we're making next iteration. Mid index is 0, which means that left would be 1. Condition is satisfied. After we should check previous solution. Mid index would be 1. After that, we're calculating this. Deltas would be 0. No, not minus 2, just 0 and minus 2. My mistake, sorry. Yes. 3 right. 3 less than num's length minus 1. No. Yeah, after that, next iteration. I equals to 1, left 0, right 2, max decrement 1. Deltas at the index of 0 would be decremented by 1, and right is 2 less than 4 minus 1, 2 less than 3. Yes, and we will change deltas, right plus 1, deltas at the index of 3 by 1. Max decrement. Here it is. And now we're checking. Current delta would be -1, -1 plus 4, 0 plus minus 1 minus 1, 4 plus minus 1, 3, bigger than 0, return false. Here we are having false. And again, and the result would be minus 1, which is okay. And let's return to the first one. Left would be 0, right would be 2. Mid index would be 1. Then this mid index would be 1, which means that we from 0 left at 0 would be minus 1, 0, 0, minus 2, 0, 0. Yep. Then current delta is minus 2. Numbers plus current delta 0, minus 2, 0. They are all not positive, which means that we're returning through. Here result would be 1 plus 1, 2. Right would be 1 minus 1, 0. This condition is met because they're equal. Mid index would be 0. And here we are again. It would be minus 1. We're returning false because we have positive numbers. And here we have this. Left would be decremented. And in the end, left would be mid incremented. Left would be 1, 0 plus 1. This condition is not met and we're returning 2. So it should work. Both initial tasks should work. What I also see here is that where we can have problems. This row, I'm not sure this is the right one, but why not? We will go through all elements and we will only stop when left would be equal to right, which means that we just cannot skip any edge between right and wrong solution. So yes, it should work. Let's check types. Length, 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 number, number, number. Mean index would also be number. Result is number, right, number, left, number. Deltas would be numbers array. I number, current delta number, return value is boolean. Well, I hope it should work. Let's check. Here we are again. I already did many similar mistakes. I should remember that. This is one of the frequent mistakes of mine. Okay. Let's try to submit. Wrong answers. Expected 0, output 1. Let's move through. Left would be 0. Right would be 0. We only have one iteration. Result is -1. Mid index would be 0. We're moving here. Deltas. Right, left, max decrement. Deltas. Left would be 0, 0. This condition will never be met because right is always 0. 0 is not less than 0. So we can only set left. And we can decrement it many times. We can decrement it by -2, -4, -6, 13, 18. This is what kind of deltas will we have. Current delta would be 0, and we will decrement it so that there will be -18. 2, 6, 10, 18. Numbers I would be 0. 0 plus current delta would be -18. It is bigger than 0. No. We're returning false. And we're moving left. Left would be 1. And result would be -1. Interesting. Oh, no. We will have true. Sorry. Sorry. We're having true here. Result would be mid index 0 plus 1, which would be 1. Yes. Then right would be -1. This condition would not be met, and we will return 1. Y is expected 0. We can decrement it many times, but we will not. return the minimum possible non-negative value of k such that after processing the first key, we initially have 0 array. This is as simple as that. We don't need to decrement anything. This is why we have to return it right in the beginning. How can we cover this case? If we already have all numbers that are equal to 0, of course we can make a condition, but I'm not sure it is a wise idea. This is a kind of corner case. Let's see what we had in the solution. How does this problem solved? They say that answer should be mid, not mid index plus 1, just mid. But in this case, my previous answers would be wrong, because, or not. So, if we say that these two conditions are enough, in this case, mid should be 1. But as a result, we should return 2. So, if mid index is 0, then why we should return if mid index is 0, then we should not check anything at all. Yes, I got it. We should say that we can assign a result here to the mid index if in final just to make it simple, if in the final version we will not check it. And that's it. Yes, no, yes, no, yes. If we are not checking it, then we should start from the right equal to length. And here it start making sense, because right may be bigger than numbers. No, it cannot. Mid-index can be bigger, so everything should work actually. Let's just try simple cases. Yes, and try to submit. Yes, beats 100% of solutions. Let's just check that everything is okay with the solution itself. True. Here is one mistake that I made. Everything is okay with binary search. I should remember that if I'm trying to find an edge between elements, for example, last elements that satisfies something, then I should do it until right left is equal or lower than right. Just as simple as that. And one more mistake that I made, I would say that I lost the case in which we can check zero length array. So I was always checking at least one element, but I forgot that we can also check the case where we don't have any queries. Okay, that are two mistakes of mine. Everything else looks good. I like these left-right conditions. I love the result. I like how we traverse this array with binary search. I like zero array search algorithms. I still don't understand why we need here +1 expression. Alright, left max decrement. Yes, I like the idea of deltas. Current delta. We can simplify it by making deltas positive, just to say that number should be less or equal than current delta. Let's do it. Here we will have plus, here we will have minus, here less or equal than current delta. No, if it is bigger than current delta, then return false. Let's check if it works. Yep. And let's calculate our complexity in terms of time complexity. Here we will have O from decimal logarithm of query's length here we will have index, and in every algorithm will here we have to traverse. Okay, let's say the whole query's length and here we will have O of numbers length. So the final would be time complexity O of logarithm of query's length multiplied by O logarithm query's length plus nums length, and space complexity would be we already have to keep all the numbers in memory, but also for every iteration we're creating this array of deltas. So it would be big O of nums length here space, and we don't have any all the other parts of the code only require constant space. So that's it. Yep, it works. Maybe we have other interesting solutions. Binary search again. most was binary search. Binary search, highly optimized and easy to understand, is good. Yeah, just the same. Yep. Great. I think that's it, guys. Thank you very much. I spent 2 hours today to solve this task. Pretty a lot, but I had 2 problems. The first one is that I puzzled how to make binary search again, despite the fact that we had binary search a few tasks ago, and I was not able to create binary search algorithm myself. So I had to look at other solutions in order to solve this problem optimally. Well, I will try to keep that in mind. Thank you very much.